Hello there, welcome to this video on graphing square root functions using transformations. We're going to go ahead and identify a, h, and k for square root functions and then go ahead and graph them from our knowledge of the parent function. Alright, so here is our prior knowledge. For my class you may notice that this is different than your notes, so I just want you to go ahead and please write in this function g of x into your notes, -3 times the square root of x plus 5 minus 4, and I would like you to go ahead and take a second, please pause the video, try to find a, h, and k. Alright, hopefully you paused it and gave it a go. I want to remind you of the structure. We have an a value that is out front. So in this case, our a value is -3. Our h value, that is always paired with our x value, and it is always the opposite. So in this case, our h value is actually -5, and then our k value is always at the end. Here, our k value is -4. So hopefully that kind of jogs your memory, and you got that right. If not, don't worry, I'll go ahead and bring up the general form for square root functions, highlighting the transformations. So again, a, this is a multiplier out front, and what a does is it causes stretch or compression. And just to give you a visual here, I'll get my good pal Slink, right? And if I'm multiplying something by a value bigger than 1, it's going to cause stretch. It's going to cause Slink to stretch here. But if my multiplier is between 0 and 1, right? Say I cut Slink in half. Hey, Woody. Right? If I cut him in half, okay, and then even more so, this causes compression, okay? What if I multiply by a negative? Well, that's going to cause reflection. Now he's tail up, okay? So those are our a values. Our h values, that causes our function to move left or right, and then our k value causes our function to go up and down, okay? So we're going to go ahead and kind of practice that, practice describing the effects on the functions. So here for our first function, we're asked to describe the effect of each parameter on the parent function f of x equals square root of x. So again, here's our parent function, and we want to describe the effect. So step 1, just identify, okay, what's our a, our h, and our k. So a is -2, h is always opposite, remember opposite, so it's -3, and our k value is -1. Alright, so what are the effects produced by this? Well, the first thing I notice is that a is negative. That's going to cause a reflection. So again, because a is less than 0, because it's negative, this causes a vertical or an x-axis reflection. So I'm going to say vertical reflection. The absolute value of a here is 2. This is 2. So that means since a, the absolute value of a is greater than 1, this is going to be vertical stretch by a factor of 2. And remember, that's going to cause all of our x values to be multiplied. The vertical values, sorry, not our x values, our vertical values, how far we go up or down, that's going to cause them to all be multiplied by 2. Okay, so there's the a value. The h value. So our h value is -3. Well, since h is -3, and that is less than 0, we're going to the left. So translation, left 3 units. And again, I don't say the negative, it's going left -3 units. Well, the direction kind of tells you its value is negative, right? Left indicates negative. And then lastly, we have k. Our k value is -1. So again, since k is less than 0, we are translation down How many units? 1 unit. Again, no need to say the negative there. All right, so there's example number 1. Example number 2. Here I have an A value that is 1/2, an H value that is 1, and a K value that is 2. So what are the effects? Well, since A is the absolute value of A, sorry, I thought I was still in red. Since the absolute value of A is between 0 and 1, this is vertical compression. By a factor of 1/2. No reflection, it's not negative. Our H value is 1. So since H is bigger than 0, we're going right. So translation, right, 1 unit. And then K is 2, so again, since K is greater than 0, we're going up. So translation, up 2 units. Okay, so that is A, H, and K, identifying them, and then knowing what their effect on the graph is. Very, very important in order to be able to do what we're going to do today, looking at graphing transformations. Okay, so let me go ahead, let me introduce you to the parent function of square root functions. So our parent function, please go ahead, circle this, and then write parent function. I want you to know what it looks like. So here's the parent function, square root of x. And we're going to go ahead and graph the parent function. Now, it's important to remember that the domain is restricted to values of 0 or greater, because if my value is negative for a square root function, I get imaginary values. Recall that the square root of -I is equal to imaginary 1i, which we don't have in Math 3, okay? So the values that we choose here are x values. These are very, very strategic. These are perfect squares, and there's a reason why I pick perfect square x values. It's because I'm plugging them into a square root function, and I want to get nice outputs. These give us nice clean points. So what's the square root of 0? If I plug this in, square root of 0, that is 0. Okay, so that gives us our first point here, 0, 0, and I put it in red because this is our anchor point, what I call an anchor point. Very important. Make sure you write that down. The next x value, 1. What's the square root of 1? 1. These aren't too difficult. So then our next point is 1, 1. Okay, the next x value I'm going to plug in, 4, the next perfect square. The square root of 4 is 2, so 4, 2. And then the next x value, 9. So square root of 9 is 3. So 9, 3. Sometimes you can fit this one on the graph, sometimes not. So just let the graph kind of tell you. And then our function looks like this. And we looked at these functions last unit. So I do have my endpoint, 0, 0. Notice I do not have an arrow. I don't have an arrow over here. Okay, so don't draw an arrow. That endpoint is an endpoint because if you go past 0, you get into imaginary land. Okay, and don't go into imaginary land. All right, so there's the square root function. All right, what we're going to do is take our steps to graph a square root function. Step number 1, you want to go ahead and identify what's A, H, and K. And then you're going to go ahead and use the 4 key points. So we're going to go ahead and use these points, and we're going to graph the transformed points and then draw a smooth curve. It's not a straight line, and I'll show you that here in a second, okay? All right, so here is example number 1. Please write this in your notes. All right, first, step 1, I'm going to identify my A, which is -2. I'm going to identify my H, which is -3. And I'm going to identify my K, which is positive 4. Okay, so there's A, H, and K. All right, first thing I'm going to go ahead and do is I'm going to translate my anchor point. So translate the anchor point. So 0, 0, that's my anchor point, and it's going to translate to whatever H, K is. So in this case, our 0, 0 is going to -3, 4. And let me color code these for you. Our H value, -3, K, which is 4. Okay? So our point, our anchor point, and I'll go ahead and bring up Desmos for you. So here's the parent function, and let me zoom out a little bit. Our H value is -3, so we're going to the left, -3. And then our K value is 4, so we're going up 4 units. And so what we're going to do is we're going to graph that highlighted point here. Okay, so I'm essentially plotting my anchor point. So I'll put this over here. So let's go ahead and plot our anchor point. Okay, left 3, up 4. Here's our first point. Okay, step 3, you're going to graph the rest of the points. And what helps people out is if they make a little chart here. So I'll say X, and then I'll say Y, and I'm going to list those points. 0, 0, 1, 1, 4, 2, 9, 3. Okay, and I'm going to treat the new anchor point as my origin. And I'll put a note here. So treat anchor point as the origin. Okay, and I'm going to go ahead and I'm going to plot my next point, 1, 1. So if I didn't have any stretch or compression, my next point would be right here. Go right 1, up 1. But I do have an A value, and my A value is -2. -2. Okay, so what is the effect of a -2? Well, first I'm going to go ahead and I'm just going to show you the effect of a 2. Well, if I have a value that's 2, that's going to cause stretch. So we're going to have stretch on our graph. And notice, instead of going right 1, only up 1, my vertical value of 1 got multiplied by 2. So 1 times 2 is 2. So here I have this value. So I went right 1, up 2. Okay, with Schwarberg, we also have the negative. Okay, well the negative, instead of going up, we're going to go down. We reflect down. So A is -2, so we're going to go right 1, down 2. Down 2, and you'll see that point, if I can get it right there. Okay, so, all right. And another thing you can do is you can take that A value and you can take all of these values and multiply by -2. Okay, and some people like that. That gives them, we're still at 0 here. This is down 2. This one's down 4. This one's down 6. Okay, and I'll talk through that. Okay, so here is our graph. Okay, so normally we would go right 1, up 1. Normally we would go right 1, up 1. Okay, but instead of going up, we have to go down. So down 1, 2. Down 2. Okay, there's my first point. All right, next, I would normally go right 4. So looking at my table, right? Normally we would go right 4, up 2. Okay, so from my anchor point, treat your anchor point as your pseudo-origin. So I'm going to go 1, 2, 3, 4. Okay, and normally up 2. But instead of up 2, I have to go down because of the negative. And then that distance of 2, I'm going to multiply that by 2, my vertical stretch value. So I'm going to go down 4. So we're going to be here at this point. Okay, and if you'll notice what I kind of did with my table here, right? I multiplied it by 2, and you'll notice, whoop, -4. I'm going down 4. Okay, now back to my chart. I'm going to plot my last point. So I'm going to go right 9. Sorry, let me show you with this. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And normally I would go up 3, but again, I'm going down, and I have to multiply the distance, 3, by 2. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. So 6, negative 2. Okay, and there's our last point. All right, lastly, I just want to draw a smooth curve through these points. I'm going to do my best, take a smooth curve, and then I'll put an arrow at the end. Notice I start at my end point, and I draw a smooth curve this way, and I put an arrow. Okay, end point, arrow at this end. No arrow at this end. If you go into this end, that's imaginary. Don't do that. All right. Just a recap of this lesson, of this example. I'll show you another example here in a second. First, we found our A, H, and K. A is negative 2. That's going to cause reflection and vertical stretch. H is negative 3, and K is 4. So what we did first is we plotted our anchor point. I translated it left 3, up 4 because of H and K. Next, I used my parent function points here, 0, 0, 1, 1, 4, 2, 9, 3. And from my anchor point, I plotted those. Okay, so right 1, but instead of going up 1, I had to go down 2 because of our A value. Then I went right 4, and I went, instead of up 2, I went down 4 because of our A value. Next, I went back to my anchor point, and I went right 9. Instead of up 3, I went down 6, again because of our A value. All right, so I'm going to go ahead and show you. I want to do another example before I have you practice. All right, so go ahead. Here's example number 2. If you have a spot where it says practice, kind of skip that. So write this one. All right, and I'm going to go through the step process again. So step number 1, identify our A. In this case, our A value is 1. I don't have stretch, don't have compression, I don't have reflection. Hey, that's good. Next example, next component, parameter. H value is 4. Remember, it's always the opposite. Okay, so that's going to cause us to go right 4. And then our K value, that's usually at the end. In this case, it is 0. Okay, so the first thing I want to go ahead and graph is I want to translate 0, 0. So do I go right, left, up, or down? Well, we are. We're going to go right 4. So 4. And then I don't go left or right at all. So 4, 0. Okay, so I'm just going to the right 4 units. Boop. So there's our anchor point, 4, 0. Okay, so that's kind of going to be like our new origin, right? So for step 3, I'm just going to list my values. So x, y, 0, 0, 1, 1, 4, 2, 9, 3. All right, and I'm going to plot these. Okay, so from this point, okay, so 0, 0, my first anchor point, or my next parent function point is 1, 1. So right 1, up 1. My next parent point, 4, 2. So back to my anchor point, 1, 2, 3, 4, up 2. Okay, and then lastly, 9, 3. Oh, good luck, Schwarberg. Okay, so that's going to be like 13. 9 plus 4, 13, and then up 3. If I had room. I just kind of want to show you. So maybe somewhere about there. Okay, and then lastly, draw a smooth curve through those points. Okay, and there it is. She's a beaut. All right, that is it. Okay, I want to go back to a practice problem. I want you to go ahead and try this example. Pause the video, give this one a go. All right, hopefully you paused this one and that you found out A was 3, H was 5, and K was -1. Okay, so that's going to give you an anchor point, 5, -1. So I would plot that first, 5, -1 right here. There's your anchor point. And then your A value is -3. So how does that affect the graph? Well, you should have had vertical stretch by a factor of 3. And vertical stretch, again, is going to affect your y values, these values. All of them are going to get multiplied by 3. So 0, 0 unaffected, because 0 times 3 is 0. But 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. So let me get rid of this multiplied by 3. That's what we're doing, right? We're multiplying by 3. And from our anchor point, we could plot those, right? So right 1 up 3, 1, 2, 3. Okay, and then right 4, 1, 2, 3, 4, up 6. Here it is. And then if you could fit it, right, you could do the last one, you would go right 9, up 9. Okay, and that's what you should have gotten. So here it is. Okay. All right, next practice problem. Please go ahead, write this function down, pause it, give it a go, and I'll show you the answer here in a second. All right. A is -1. You're going to have reflection on this one. Hopefully you caught that. H is 0, K is -2. So our anchor point was now going to be 0, -2. So down 2. There's your anchor point. And then your chart, x, y, 0, 0, 1, 1, 4, 2, 9, 3. All of these values are going to get multiplied by -1. So the 1 becomes down 1, the 2 becomes down 2, and the 3 becomes down 3. So from my anchor point, from 0, -2, I'm going to go right 1, down 1. Right 4, down 2. Right 9, down 3. Okay? That's how you get your points. And the function should look like this. All right. Closure. Closure. Which function represents the graph of the square root function shown? Explain how you know you have chosen the correct answer. So go ahead, please look at this function and identify what's the correct function. Is it A, B, C, D, or is it E? Pause the video, give it a go, and I'll show you the answer here in a second. All right, so looking at this one, a good way that you can right away rule some answers out is by just looking at the endpoint. You go from 0, 0 to -1, -3. So that means that your H value is -1, and it means that your K value is -3. So right away, just looking at the K value, I know E goes out the window. Whew, that's gone. Our H value is -1. Well, I have to flip it. I have to flip that, right, in our function. So A is out, B is out. So C and D both have the correct H and K. And then lastly, okay, the difference between C and D is we have an A value of 2. So do I have stretch or do I not? Well, my next point should be right 1, up 1, but we go up 2. Correct answer, D. D is the correct answer. All right, thank you for watching this video. Please give it a thumbs up, like it. Go ahead and subscribe for some awesome math videos. I'll catch you next time. Be safe, be easy, peace.